Welcome to another video tutorial for learning music theory with Logic, Max, and Finale, published by Routledge and written by Jeffrey Kidda. In this video tutorial, we'll talk about melody. We'll talk about how melody makes use of motives and how we can operate on those motives. We can change motives by transposition, inversion, retrograde, augmentation, and diminution. We'll talk about how we can use Logic's MIDI transform and Finale's canonic utilities to do these operations. And we'll take a look at the diatonic melody generator, a Max MSP patcher, which allows us to create melodies from motives and also to manipulate the motives or to operate on the motives in the ways we've discussed. We might start by asking ourselves the question, what makes a melody and how can it be defined? Those are actually difficult questions to answer, but we could start by saying melodies can be based on scales and chords. Handel's Joy to the World is clearly based on a major scale descending, and in the second part of the first phrase, an ascending major scale. Strauss's The Blue Danube Waltz is based on a major triad and arpeggiates that major triad. Melodies often have recurring motives or motifs. Motives are short melodic or rhythmic units which are combined to create melodies. Melodies can vary motives by these operations: transposition, inversion, retrograde, augmentation, and diminution. And we can combine these operations in various forms. A Fine Romance by Jerome Kern and Dorothy Fields has a rhythmic motive that's heard 3 times in the opening. The rhythmic motive is a quarter note, half note, quarter note, whole note. Beethoven's Symphony No. 5 has a very recognizable motive: 3 short notes followed by a longer note, which is a descending third below the first 3 notes. And we hear this throughout the symphony. In the very beginning of the symphony, we hear in the 4th iteration of that motive a variation where instead of a descending third, Beethoven writes a descending second. Transposing a motive up or down several times creates a sequence. Sequences that remain in a key are tonal. Sequences that duplicate the initial motive's intervals are real. Real motives will often have notes that are outside of the original motive's scale. Logic's MIDI transform transposition preset transposes motives chromatically, and these can be made diatonic by scale quantizing, which constrains selected pitches to a selected key. Sometimes additional editing is needed to maintain the motive's original shape. Finale's transposition tool allows the user to transpose both diatonically and chromatically. The upper line is a tonal sequence. The lower line is a real sequence. First, we move the motive into the first 4 measures. Then we select the second measure and transpose it diatonically up a second. And then we transpose the 4th measure and we transpose it up a second chromatically. Inverting a motive means to create a mirror image of the motive, whereby every interval is heard in the opposite direction. Inversions can be real or tonal. Here, the second measure has a real inversion of the motive in the first measure. The third measure has a tonal inversion of the first measure's motive. These inversions are based on the initial pitch, which we call the axis of inversion. The axis of inversion is the pitch around which the inversion is created. Logic calls it the flip, and in Finale, it's called the pivot. Logic's MIDI transform reverse pitch creates real inversions. The flip is set to G4, the first pitch of the motive. Copying and pasting the motive, MIDI transform reverse pitch, and finally scale quantize. Finale's canonic utilities allows us to create both real and tonal inversions. The pivot note is set to C5, the first note of the motive. Copy and paste the motive, canonic utilities diatonic mirror inversion, canonic utilities chromatic mirror inversion. Logic's MIDI transform reverse position can retrograde motives. It's also possible to retrograde motives by manipulating the time handles in the piano roll editor. The selected portion, based on the position markers, is retrograded, as we can see in the MIDI transform. Copy and paste motive, MIDI transform, reverse position. Finale's canonic utilities retrograde setting allows us to retrograde selected notes. Copy and paste the motive, canonic utilities retrograde setting. Augmentation lengthens rhythmic values in a motive, and diminution shortens rhythmic values. The rhythmic values in the motive below are first doubled, then halved, with MIDI transform's half speed and double speed presets. Copy and paste the motive, MIDI transform half speed, MIDI transform double speed. Finale's change note duration allows the user to apply augmentation or diminution to selected note durations. We can learn about how motives are operated on in real music as well. If we look at J.S. Bach's Invention Number 1, we'll notice a number of operations of the first motive. In its first 5 measures, several diatonic transpositions and inversions with transposition of the initial motive are heard, as well as one chromatic inversion with transposition. Here we have the actual music of the first 6 measures of Bach's Invention Number 1 with the motive and the transposed forms of the motive shown as well. And we'll notice that in measure 5 we have a transposed and an inverted and transposed version of the motive, which has an F sharp, and that pitch is outside of the key of C major, so we know that it is a real transposition and a real inversion with transposition. The diatonic melody generator allows us to combine motives to create a melody. Here's how it works. The first thing we do is select the motive length, either 3, 4, 5, or 6 pitches. Then we set the melody length. The melody length will be a multiple of the motive. So for instance, if your motive length is 4 pitches, your melody length could be 16, in which case you're going to hear 4 motives or 4 instances of the motive. Once you have selected the motive length and the melody length, you can input the pitches for the motive on the keyboard, and you can input the rhythms for the motive with the motive rhythms section. We can also select the key and the scale for the melody. And below the keyboard, we see 4 message boxes with the words prime, retrograde inversion, and retrograde inversion. What's shown here is a 4-note motive, and those 4 message boxes show how we have, first of all, the prime version of the motive, which is how we input the motive, and then a backwards version of the motive, which is the retrograde, and an inverted version, and then also a backwards and inverted version of the motive. Similarly, with the rhythms, we have the prime version, which is how we input the rhythms, and then a backwards version of that, which is the retrograde. Once we have input our motives, both the pitch motive and the rhythm motive, we can combine instances of them into the pitch melody and the rhythm melody. We have the 4 forms, prime, retrograde inversion, and retrograde inversion, and we can transpose any of these up and down with the transposition dial. For the rhythms, we can either choose the prime or the retrograde version of the motive. And once we have put enough motives together in the pitch melody and the rhythm melody, then we can join the pitches and rhythms by clicking the Join Pitches and Rhythms button, and this produces the melody in the lower message box, which we can then listen to. First, we input the pitches for the pitch motive, then we input the rhythms for the rhythm motive, then we add together 4 of the rhythm motives for the rhythm melody, then we select 4 motives for the pitch melody, prime, prime plus 1, inversion plus 6, and inversion plus 4. The motive that we showed in this diatonic melody generator has the numbers 0, 2, 0, 4, and these represent scale degrees, although scale degrees with 0 being the tonic note, so that the 2 is actually the 3rd scale degree and the 4 is actually the 5th scale degree. This is because programming starting with a 0 as the first element is easier than having it be 1. So in each case, we can see that we're actually talking about scale degrees, but they're 1 digit off. Also, the negative numbers are the scale degrees below the tonic note of 0. We can take these 4 forms and see what they look like in D major and in F minor as well. The motive that we created, 02, 04, is seen in the first measure here. Then we transpose it up 1. Then we have the inversion transposed up 6, and the inversion transposed up 4. The rhythmic motive is the same, and we use that 4 times to create this melody. Another use of the diatonic melody generator is to randomly create the elements and put them together. This is an exploration of algorithmic music in which we get the computer to make some of the compositional choices. In this case, you can randomly generate pitch motives and rhythm motives, and then you can randomly generate pitch melodies and rhythm melodies to then put together for a melody with pitches and rhythms. Random pitch motive, random rhythm motive, random pitch melody, random rhythm melody, join melodies. Thanks for watching.